All right. How's it going? My name's Adam Bardak,
I'm Nick Petrarca.
Tom Adams.
and we are doing our experiment presentation on modeling the pandemic. So just a little brief overview on the problem statement. So over the past year and a half, the United States, as well as the rest of the world, has been put in a really unprecedented time just because of COVID. In the past 6 months, a lot of vaccines have been given the green light to be administered throughout the country as well as the rest of the world. In our experiment, particularly, we were focusing on the United States, in researching how these vaccines have influenced peak infections periods using data from the CDC as well as the University of Oxford. So the basis of this model will be the standard susceptible, infected, and removed epidemiological model. So this is very important to understanding what factors affect the peak infection periods and how this can overall benefit the country as well as the rest of the world during this very hard time.
So the basis of our simulation was the SIR model, as mentioned before. You can see it's a system of differential equations that you can see in the top right. To incorporate new vaccinations, we actually added another term to the removed model, just based on our analysis of how many new vaccinations were happening each day, and different terms for how fast that rate is accelerating. There are also two factors which we decided to include in our experiment that are in the SIR model: beta, which is sort of the effective contact rate, how often an infected individual comes in contact with a susceptible person, and then lambda, the rate at which susceptible individuals actually contract COVID-19, can also vary. So our experimental design incorporated these two things, the contact rate and the contraction rate, as well as 3 different levels for vaccine efficacy based on the CDC 95% confidence interval and mean, and then also 2 different rollout rates for the vaccine, just a linear accelerating rate and then also a cubic rate which peaks and then comes back down as more people get vaccinated. And we use JMP to generate a custom design for this.
Then just a little bit about our data. We got a data set from Kaggle that shows different countries and their vaccination rates and transmission rates. But for this project, we just wanted to focus in on the United States. Using the data, we can see how the number of people that are vaccinated, the total vaccinations per country and per capita, and then the daily vaccination numbers as well. We can use this to compare each location's vaccination rates and the which vaccine is being used in which location as well. Here are our sources, and thank you for listening to the presentation.